So welcome back to our next statics lecture. In this lecture, we're going to be talking about other things that you should have learned in physics. Hopefully, this will be review. And we're just basically going to be talking about dimensions and units. So what are dimensions? Dimensions are our sort of fundamental properties. And what are they? They're basically, we're going to have length, which I don't think I need to define, and we're going to have time and mass. All right, and we talked about mass last time. Mass is basically an intrinsic property of an object. Time, I think we understand what length and time are. All right, and so these are sort of the fundamental dimensions, but then there are some sort of derived properties, and the two that come to mind are velocity, which would have dimensions of length over time. And notice when we write dimensions, we put them in brackets. Hopefully it's your established practice. Elsewhere in acceleration, there's another one that we're going to see, which will have dimensions, of length over time squared. And the other, well, we'll leave it at that. Dimensions. So what are the basic units that we're going to be dealing with? And I'll do here, and we're going to divide these into what we call SI units, which formerly called metric units. System, international. So the length would be meters, time would be seconds, and generally the mass would be kilograms. And then the US customary units that we are typically used. Hopefully someday we're not going to be using them, but still are used. And length typically are feet. Time is seconds. And not really, well, there is a mass unit. It's not very, I'll put it here in pound mass. Sometimes referred to as slug. But usually what we see in US customary units are weight force. It's more of a sort of a dimension used in US customary units. And I'll put it down here to be pounds. Okay, we all know how, and obviously for force, we have a SI unit. It's not like what's considered like one of the fundamental dimensions, but the force would be in newtons. Okay, so these are all the units that we're going to be dealing with. You're not going to see this very often. In most cases, we'll say you may have like a applied force of 1,000 pounds, 10,000 pounds, applied to some beam, for example. Is there anything else that we need to deal with here? Let me just look at my, oh yes, prefixes. So I'm going to erase the board, and then I'll come back and we will deal with prefixes that are applied principally to SI units. So, all right, hi, I want to talk about prefixes that are typically applied to our SI units. So we're talking about prefixes. I can't spell. Prefixes. I'll put here the prefix. Well, we'll create a little table. K is kind of a typical prefix, which applies our what we call thousands. So if you see something like km, like 10 km would be 10,000 kilometers, right? M for meters, K is the prefix. So other prefixes that you're going to see are a capital M. Don't see it that often, but maybe not in statics, in other fields like astronomical distances or something where you have very large numbers. Anyways, that's a million. And the other one that we're frequently going to see is a lowercase m, which can be confusing because that's also meters, right? So you're only going to, if you see like two letters next to each other, it'd be like millimeters. And this one is 0.001. So if we have if we have 10, if you see something like that, it's 10 millimeters, or 10 times 0.001 meters, or 0.01 meters, right? It's 10 millimeters. There was something else I wanted to mention, which is, if you have compound units, sometimes you'll see these, just to be clear, if you have if we want to have units like meters, seconds, you have to be really careful because you have to put m-s. If you just put ms together, it looks like milliseconds. So this is not equal to that. So meters seconds would be m-s. So whenever you have two units together, or excuse me, two units together, like in a compound unit, you always make sure you have a dash in there, okay? To make sure there's no ambiguity. All right, so that's prefixes. The other thing you need to be aware of, and hopefully this is not going to be new to you, is, so again, these prefixes are used only for SI units. They can be really handy, because imagine you have, like, if you're dealing with commonly like thousands of newtons, let's say, it's a lot easier to write 1.3 newtons than write 1300 newtons, because if we have like a long equation, then, I gotta look over here, if you have a long equation, you're gonna have a lot of like very big numbers. This enables you to keep the numbers like in relatively small packages, let's put it that way. All right, prefixes. Oh, the other thing I wanted to mention was scientific notation. So I'm going to erase this. So just be aware there are many other prefixes, but these are commonly the most common ones that you're going to see in this class, in statics class. The other thing that we commonly use is scientific notation. So sometimes you'll see something like, with scientific notation, it's just saying times, some number times 10 to raised to power. So for example, I wrote 2, let me try this again. If I were to write 2.95 times 10 to the third, that's just going to be 2,950, right? Because 10 to the third is 1,000. All right, I'll put a comma there. All right. The nice thing about scientific notation, again, like the prefixes, enables you to write like small numbers. You don't have to put a bunch of zeros or have a decimal point and a bunch of zeros in front of it. Scientific notation is great for that. I'll also mention that these exponents can be negative. So you have 2.95 times 10. Negative third, which would be equal to 0.002. I lost a zero here. Sorry, 0.029. 5. Okay, those are equivalent. Now, another nice thing about scientific notation is when you start multiplying and adding these numbers, you can just add not adding, but when you start multiplying and dividing numbers expressed in scientific notation, you can just add or subtract exponents. So I'll just give you an example here. Let's just pulling these numbers out of the air. 2.95 times 10 to the third, like we had before, and I'll have 5.78 times 10 to the fourth, and then I'll divide by 7.20 times 10 to the fifth. Okay, see, what we can do is we can take all these tens and pull them all together, and then if you're multiplying 10 to the third times 10 to the fourth, that's just 10 to the seventh. And then dividing by 10 to the fifth means you end up with 7 minus 5, 10 squared. So all this long term would be equal to 2.95 times, or I won't write it like that, sorry. I'll put it in parentheses, times 5.78 divided by 7.20. And so we have 3 plus 4 is 7, minus 5 is 2, so that's all times 10 squared. So it's just an easy way of reducing terms. Help you to like look at numbers and make sure that once you've done this in your calculator, you can look at the result and say, oh yeah, this is like 3, that's 6, 18, divided by 7 is like 2.5, so it should be somewhere around 2.5 times 10 to the second. Just you can do that kind of in your head. Otherwise, when you look at these, you can't really do that. All right, so we've talked about dimensions, units, prefixes, and scientific notation. And that's all for now. I'll see you in class.